Hello, we're from ChemPraxis, and today we'll be discussing Chemistry Paper 5, Variant 3, May-June 2021. We'll be investigating the rate at which hydrogen gas is made when magnesium reacts with dilute sulfuric acid. First, use a 25 ml measuring cylinder to pour 25 ml of dilute sulfuric acid into the conical flask. Next, use a 50 ml measuring cylinder to pour 30 ml of distilled water into a conical flask. After setting up the apparatus like so and ensuring the inverted measuring cylinder is full of water, prepare a bung and add a coiled length of magnesium ribbon to the conical flask. Close the conical flask using the pump immediately and start a timer of 30 seconds. Record the volume of gas collected after the timer runs out. Now, repeat the first 3 steps, except this time use 20 ml of distilled water instead of 30 ml. After recording the results, repeat the experiment again using 10 ml and no distilled water respectively. According to the results, we can see that the lesser the distilled water is added, the more the volume of gas is collected in 30 seconds. Using the table, we'll be able to create the graph for question B. After extending the line, we'll be able to see that if 35 ml of distilled water was added to the dilute sulfuric acid, we can predict that the volume of gas collected in 30 seconds is around 19 centimeters cubed. Using the table, we can see that the volume of gas collected in experiment 3 is 60 centimeters cubed, and the time taken to collect the gas is 30 seconds. So, subbing this value into the equation, our rate would be 3 centimeters cubed per second. A pipette has more specific values in measuring than a measuring cylinder, however, it would be slower to use. A gas syringe can replace an inverted measuring cylinder as it can also be used to measure the gas collected. For question G, using this type of conical flask does not require a stir up in the pump, hence it would avoid the risk of any gas loss to the surroundings. For question 2, we'll be finding out what is within solid I and solid J. Add aqueous sodium hydroxide dropwise and then in excess into solution I. We can observe that a green precipitate is formed and it dissolves in excess. Add aqueous ammonia until no further change can be seen. We can see that a green precipitate is formed and remains undissolved. Add about a 1 cm depth of dilute nitric acid followed by a few drops of aqueous silver nitrate. Leave the mixture for about 5 minutes. We'll be able to observe that a white precipitate is formed. Add about a 2 cm depth of aqueous sodium carbonate. We can observe fizzing and the forming of a grey-green precipitate. Throughout our experiment, we can see that chromium and chloride is both in solid I. Now, let us find out what solid J is by doing a flame test. We'll be able to observe a yellow flame formed. Add about 10 milliliters of dilute sulfuric acid in solid J and test for any gas. We'll be able to observe fizzing and that the lime water turns milky. These indicate that carbon dioxide is present. After placing solid J into a test tube, add about 10 milliliters of distilled water and place a stopper in the test tube. Shake the test tube to dissolve solid J and form solution J. Remember to divide solution J into 2 separate test tubes. Take the first portion of solution J and add about a 1 cm depth of aqueous sodium hydroxide. We'll be able to observe that there are no changes. Add about a 2 cm depth of aqueous copper 2 sulfate into the second portion of solution J. We can see that a blue precipitate forms. Throughout our experiment, we can see that solid J contains sodium and carbonate.